How's it going, everybody? I'm Joe, as introduced. So hopefully this session's been great for you so far. It's pretty cool seeing data engineering as a topic at ODSC. So let's get started. Data engineering is a very hot topic these days. I think it's a very hot career field as well. And you might have some questions about it. Well, it's a hot field, but how do I get into this field? So that's the purpose of this talk. So start showing my slides here. And I get, if you do have questions, I would say please put them into the chat, and I'll address those after I'm done with my talk. So let's get started. Make sure I can share my screen here. It says it's paused. Let me see here. Let me start sharing my screen again. Can everybody see my slides okay?
No, actually, we can't. No worries.
Okay, here we
Let
go.
me just.
It looks like it's showing right now.
I still see only.
Hello? Hi, sorry. Technical difficulties here. Just 1 second. Can everyone see the slides okay? Okay, so it's
any slides at the moment.
Okay.
I'm sorry.
Yeah, Mariel Roth says she sees it, and I can see it in mine. So I'm going to assume people can see it, and we'll get going. So yeah, getting into data engineering, 2023 edition. So let's get into that. Okay, so why should you care about this this talk here? Well, there's a lot of advice on getting into data engineering, over the last several years. And I would say this also applies to data science, right? So there's no shortage of advice, but the question is, what advice do you listen to? The job market is way different than it was last year and in prior years for very obvious reasons. Interest rates are increasing in most economies around the world. That causes the economy to slow down, and here we are. So the job market is changing. Data engineering is also changing, right? So I might get into a bit of what that means, and you should care because you're here because you want advice on this, right? So this will be a pretty practical discussion, and I'm not going to be very hand wavy about things. And again, I want to make this interactive with the audience. So as you have questions, throw them into the chat here, and we'll get to them. So what I'll cover in this talk is what is data engineering. We'll level set on the definition of that. We'll talk about what's changed in 2023, and then I'll give some various career tips for entering the data engineering field from various points, right? So you might be a software engineer, or you might be data scientist or analyst, or you might be none of the above. You might just be getting into the field for the first time. So I just want to make sure that everyone's accounted for here. So who am I? Well, I'm Joe. I wrote the Fundamentals of Data Engineering along with my co-author Matt Housley. I think it's been doing pretty well. It's a top-selling book. The response has been overwhelmingly better than I ever expected. I think it's a testament to where the interest in data engineering is right now as a field, and so that's pretty cool to see. I've got over 20 years of experience in the data profession, and I, moonlight as a speaker, professor, podcaster, blogger, mentor, and much more. I also run a company called Ternary Data. We do boutique data engineering consulting, and so enough about me. Let's talk about what is data engineering. There's lots of definitions, right? So, I maybe for the next minute, maybe if you could just type in some definitions into the chat about what you think data engineering is, I'll look at these and, so I put some definitions here. There's on the screen, data engineering is the science of collecting and validating information, such that data scientists can use it. Kirsty Hawk says building reliable pipelines. That's cool. Let me see a bunch of people typing here, so I'll give you guys a few more seconds here. Type this. Okay, so Omar says data extracting and loading to enable analysis and data science. I like that. Justin McCack says building the infrastructure that enables data users to do their jobs. I like that one. Ditya says it's about extracting data from various sources, handling, transforming for analytics. Yeah, these are all good definitions here. Continue adding your definitions. I'm always curious to see what people think about what data engineering is. William says data engineering is a field of implementing data utilization. I like that too. So you see some common themes here, right? It's data engineering is an enabling function, right? It doesn't kind of exist in a silo on its own. There's it's meant to serve others. So let's get into the definition we have in the book. This is a very long-winded answer, but so I'm not going to go through this. But this kind of shows, one definition of data engineering, right? It's the intersection of data management, data ops, and so forth. And you're developing, implementing, and maintaining systems that take in raw data and produce high quality, consistent information that support downstream use cases, right? But at the end of the day, the TLDR on data engineering is you get data from sources, you make it useful, and you serve it to stakeholders. That's really about it. And again, I think the motivation for why data engineering might be popular is because maybe it reflects the experience that I've had. I started out not in data engineering, but I sort of sat at this intersection of software engineering and data science, and this was back in the 2010s. And through that decade, data science was really it's the hottest job in the world and so forth. But over and over, I kept noticing, and so did other data scientists, that the field really felt like it was jumping ahead of itself. There's a lot of interest in algorithms and building models, but when it came time to deploy the models in production, it was a bit, it was a bit mysterious in how to do this. And so companies were hiring data scientists, and I'd argue not giving them the proper foundation for success. And so that's why I got into data engineering. And so yeah. So in the book we talk about the data engineering life cycle, right? And so this is I think the big idea of the fundamentals of data engineering book, where if you take a step back and try and figure out what's not going to change in data engineering over the next 5-10 years, this is really a lot of this is I think fairly immutable. Like you'll never have a situation where you're not going to get data from something that generates a source that generates data. You're never going to have a situation where you're probably not going to somehow ingest it or store it or transform it or serve it, right? And and undercutting this life cycle is are things like security, data management, data ops, architecture, orchestration, and software engineering. Again, these are all at each stage of the data engineering life cycle. Really, these are considerations that really help make that particular stage successful, right? So security is one of these things where it's never going to go away, no matter where in the life cycle security is. It's not like you would put security over or in the systems that generate data generation, that box over on the left here, but then you'd ignore it in serving, right? Like security has to exist and across the life cycle. So what this does is it really provides a framework to think about how data engineering should be performed and thought about. So I see some questions. So I'll get to your questions in just a bit, but these are good questions here. These are the undercurrents. It goes into these a bit more detail. Again, security, data management, ops, architecture, orchestration, and software engineering. So why these are important, I would suggest, if shameless plug, if you want to learn more about this, read the book, Fundamentals of Data Engineering. But you're here to learn about how to get into data engineering. So let's go over that real quick. So what's changed in 2023? Well, the job market is obviously very unpredictable at this point. I don't know what's going to happen even next month. I don't know that anybody else really knows. And if they claim that they know, I would be very skeptical. So people say recession is predicted to happen. That's seems to be the overwhelming consensus of economists and traders. And so the thing with recessions is that they can be a self-fulfilling prophecy to a large extent, and so that's I'll be curious to see what happens. The depths, and the severity of the recession, who knows? Everyone has an opinion, but again, I don't think anyone knows for sure. So again, there's lots of uncertainty, especially for people new to data engineering. So how does this impact the data engineering jobs in 2023? I really don't know. So I wish I could give you a better answer. I do see that data engineering is, there's still a lot of companies hiring data engineers. What I have seen is like data science jobs are becoming fewer and far between. While data engineering seems to be holding steady. Again, this is anecdotal. Don't take this as job advice, but I would say that this is part of the more macro trend I've seen where data engineering has become more popular and relevant precisely because I think people are now realizing, companies are realizing they need to invest in the foundations to make their data scientists more successful. So will data engineering, where's it going? Hopefully, upwards and onwards, but recessions have a way of surprising people. So I honestly, I'm hopeful, but we'll see. Career paths I'll discuss. So if you're new to data in general, we'll discuss that. I think this is worth talking about. Moving from a software engineer to a data engineer, and then moving as a data scientist or an analyst and a data engineer. So let's go to the first one. If you're new to data in general, this is you're entering the field, I would say, at a very interesting spot, right? Downturns, I think, have a way of they can be a great opportunity, and they can also be very, very frustrating for obvious reasons, right? I mean, if you're new to the field, you don't really have the the experience that you can fall back on and can show to people. And so all you can do really is it's very similar to what the advice in data science is for entering a job, a job market like this. So, focus on building your data engineering portfolio. There's a lot of great materials online about this from people like, Andreas Kratz, Seattle Data Guy and so forth, Zach Wilson, and many others, right? So I would just, look at what they suggest and probably start building something like that. Your engineering portfolio should really encompass, I would say, a mix of understanding like the fundamentals of the underlying technologies you're showing, as well as the fact that you can communicate, right? And the fact that you can obviously tie those together to explain, maybe how a technology works or how a workflow works and so forth. So the things I would look for really if I'm hiring somebody who's new is, are you eager to learn? Do you have an aptitude to learn? And can you demonstrate this through good communication? So I don't think this goes away, but more, nowadays this is what you got, right? So the next thing is, apply for jobs. Easier said than done, and I would say this is very frustrating. You might be applying for hundreds of jobs if you're new, and it is what it is. You have to just my thing is you have to treat it like a salesperson does their quota, right? So you have a conversion rate at some point. You probably will get a yes at some point, but you might have to be applying a lot, if the conversion rate. But the thing is, it only takes one, right? It's not like the difference between sales and getting a job is sales is very much a continuous thing where you have to keep getting clients. I would say with getting a job, hopefully the job you land is the job you land. So. And it just takes that one job. It takes that one opportunity, then your career changes. And I would say after you get that first job, that's pretty cool because now you have something to fall back on, and you can stay there for a year or two. Then I think it's the rest takes care of itself. Your first job is always your hardest job to get. That's just how it is. So the other advice I'd have is build your network. I think all of you are at ODSC because you're motivated and you want to meet like-minded people, and that's pretty awesome. All of you are here, and so. Your network is your net worth, as the old saying goes. I can't understate this enough. Your biggest asset in your career, from day one to build, to day in when you retire is your network. That's it. So you got to build that. Also remember, don't take shortcuts. The world is a very small place, and so don't cheat your way to the top. You will be found out. What I mean by that is like don't take shortcuts in your career. Right? So don't do things that are going to damage your reputation. As the old saying goes, it takes a lifetime to build a reputation and 5 minutes to destroy it. So always keep that in mind, and just keep building your network and treat each day as a new day, and stay positive. I know when you're applying for work, it can be frustrating at times. It's like you feel like you're, throwing resumes into a vacuum, and it is what it is. And in a recession, it's just going to be that much harder. So that's why building your network and getting out there is super, super key. So again, stay positive. I've been there myself many years ago. If you're coming into the field from a software engineer to a data engineer, I mean, what's great is you already have the mechanics of building great software and maintaining it. That's cool. So the thing you need to learn, obviously, is data. So I mean, if you're at a company where there's a data function, I would say to start working more with the data team. That if they have a data engineering role, see if you can switch into that role. So I mean, I'm seeing this more and more too, where and we'll talk about the data scientists and data analysts next, but companies, I would say, it's so hard to hire data engineers right now that it's sometimes better off, you know, doing internal hire. Because the internal hire path, the nice thing is you already have the domain knowledge of the company, so it's like you have to restart everything. So I think that's pretty cool. But again, this is the path I would say if you want to go from software engineer to data engineer, this is how you would do it. Your biggest obstacle is going to be learning how just the nuance of data and why that's different from software. But let's say you're a data analyst and data scientist, and you want to become a data engineer. I mean, that's my path. The cool thing is you know what you need, right? So you know the outcome. So as an analyst or a data scientist, you know the data set that you need. You know what you need to do with it. The things you need to work on though is probably software engineering, right? Understanding how data systems and just basic engineering work. They see time and time again the big downfall of a lot of data scientists, for example, is code's pretty bad. So right, because you're scripting, you're just writing things out so you can either build a model or do analysis, right? Your job isn't to build systems code, right? But this changes when you're a data engineer. Now you have to think about systems and how what sort of code is going to be performed in production. This is a much different thing. But the nice thing is, again, you know what you need, right? You know the outcome. So I would say, if you want to switch from being an analyst or a data scientist into a data engineer, start working more closely with the engineering teams, right? I mean, it's a great way to start. And I would say in general, like, yeah, as you become, this is something we should do in your career. Just find out how other teams work, sit with them, and really understand their workflows. I see no downside to this. In fact, it builds a lot of empathy, across different teams. What I really see hampering teams is kind of siloing off these functions where you're a data science team or your data engineering team or your software engineering team and so forth. So it's something to keep in mind, as you progress in your career, really look at how you can help people, upstream and downstream from you. This makes you invaluable. And the other piece of advice, which isn't on here, is like your first day at your job, right? Try to understand how your company makes money. I would say that's like one of the most underrated questions that goes unanswered. But if you understand how the company makes money, everything else falls into place from there. So, general career advice, again, think outside of your domain, think outside your silos, empathize with upstream and downstream stakeholders, which we just talked about. Keep building your skills and knowledge. I mean, you're all here at ODSC because, it's, you're here to learn, right? I think that's really cool. That puts you into the top, single digit percentile of people, who are, investing in the careers. I think that's really awesome. So, keep doing that. Understand your network is your net worth. Again, like the number one thing you got to keep building is your network. That's going to give you the opportunities you won't get otherwise. What I see over and over, especially in a job market like this, is people ask for career advice. I'm like, okay, so who's in your network? They're like, well, nobody. I didn't take the time to build it. It's like, okay, well, it's going to be that much harder, right? So start now. And again, stay positive but realistic. This job market, hopefully, it'll stay healthy. But again, there are things you can't control, right? You can't control what the Federal Reserve does to interest rates, but what you can control is how you respond and how you act every day, right? So bring your best version of yourself. Let's jump to Q&A real quick. I'm going to stop sharing my screen here. If you want to get a hold of me, there's my email, Joe@Ternary Data. You can also find me on LinkedIn. But yeah, let me get some questions here. I think that there's a lot of good questions here, a lot of enthusiasm, so I'm really stoked about that. Let's see. So can I get a kind of a show of hands from the audience? Like, how many people are new to the data engineering field versus are currently working in the data field in general? Let me ask you that. So there's some questions about data engineering portfolios, and so I'm going to talk about that real quick. I think that's a question that I keep getting asked a lot. I did a video on that a while ago, so if you can go search for it on YouTube. But I would say that the data engineering portfolio It depends on your purpose, right? And so I would say that it should be a combination. So here's what's different about data science or data engineering portfolios versus data science portfolios. Data science portfolios are such that the code is very evident, right? If I get a notebook with say pandas and scikit-learn code, it's like, I can I can get a data set, morph it in pandas, and then create maybe a scikit-learn model, right? Same with PyTorch and so on and so forth. And the thing is, all these steps are very evident, right? The big difference with data engineering is you're building plumbing, right? And so this is something I cannot understate enough. Like you can't you can describe in steps sort of programmatically how you would build maybe a data pipeline, say. The big difference though is there all say that you're spinning up some infrastructure in AWS, right? You can't see that, unless you go into AWS and kind of look at what's happening in the in a CloudWatch console or similar, right? And so what I would suggest for a data engineering portfolio is it should be a mix of code and video and some writing. Video though, like take when you're maybe doing a portfolio project on building a real-time pipeline with say Kinesis or Kafka, say into a data lake or Redshift or something like that, in AWS, you know, make a video of how this works and explain what you're doing verbally. Um, this will show me, okay, your steps. How did you do this? It would be like if I looked over your shoulder, or you're looking over my shoulder. We're kind of going through, a workflow. Like I think that's really, really important because again, a lot of the stuff is invisible, right? Like I can't really, for a lot of reasons, code that's written in a notebook that tries to talk to the cloud, there's just a lot of complexities with that, like security, permissions, networking, and all this other stuff, right? So if you can just make a video of it, I think that's pretty awesome. And again, the other thing is like write up what you did, step by step, written now, because I want to see, okay, so how well do you communicate? I saw whoops, sorry. So how well you can communicate through your video, but now in your verbal communication, but now I want to see how well you can communicate in written form, right? And so again, the purpose of a portfolio is really to show not just that you can walk through a recipe of things, but it's to show um, how well do you understand what you're explaining to people, and how well can you explain that to people, right? That's the bottom line of a portfolio, in my opinion. Other people probably have other opinions on that, but that's how I look at portfolios. Is it's and maybe and the great portfolios too are ones where I would say you show a level of enthusiasm. So it's probably a project you're just naturally excited about, right? I don't know what that is. That's up to you to decide, but that you know those types of projects I can just sense like the enthusiasm, and it's not just some the boring ones really are like I think it's us in data science, which everyone would do stuff on like the Titanic data set or something like that, or it's just like there's no level of enthusiasm for like a boat that sunk like over 100 years ago hitting an iceberg. Like that's like the most boring example possible. So come up with a data set that's really interesting, that you want to, and the project will kind of take care of itself from there. So let me see here. There's a question here. What programming languages should I start learning to become a data engineer? That's a good question. I think the generic answer would be something like Python and SQL. Python has sort of become the lingua franca of just data in general. And so understanding Python is, I think, great to start out with. SQL for obvious reasons, that's how you would interface with data in a database. But then I think it depends upon, I would actually take a step back, and you should understand how programming languages work. I think if you have a grasp of how programming languages work at a fundamental level, this gives you a much better opportunity to not just pick up Python or SQL, but other languages, right? Like Rust, for example, is becoming I would say that might be the next data engineering language. It's hard to say, but if you understand how a language works and how to program with a language, no matter what it is, this makes you a much better programmer or developer versus say that you just learn Python, and that's kind of all you know. I'd say, just so that, basic computer science would be something I would study just to understand basic just principles of just, programming best practices, for example, right? Like understand big O notation, right? If you have like 5 for loops in a row, it's probably not a great thing. You're gonna suffer for that, but that's easy to do, but you probably won't want to do that if you knew why you shouldn't do that. So yeah, that's let me see. Just gonna go to some of these lists. There's a lot of questions. How valuable is the knowledge of PySpark as something that can be applied on cloud platforms? I would say PySpark, it depends where you're working. PySpark's useful if you're using Spark, right? But I would take a step back and understand, so Snowflake, for example, they have Snowpark, right? And that operates on a data frame paradigm. So the word data frame might be familiar to you. There's the Pandas data frame, there's the Spark data frame, there's Snowpark's data frame. So, take a step back and understand, okay, so what is a data frame? Why would I use that versus a regular database table? So again, it's kind of like, as I said in one of the slides before, you got to understand the fundamentals. Like, I think all too often where I see people get into trouble is they jump right into trying to focus on the technology and don't understand the bigger picture of where this technology fits into, right? So, and again, this is where somebody like me who would be hiring, data engineers across all skill sets, the thing I'm going to look for too is just like, how well do you understand what you're talking about, right? And by that, I don't just mean like how well do you understand like various, the PySpark API, for example, but more fundamental questions like, what is a data frame and a data set, and what's the difference in Spark, and why would you use these, and like, why would it be a bad idea to use for loops when you're using a distributed system like Spark, for example, right? These are the kinds of questions I'm going to ask. I'm probably not going to ask you, explain what how the flat map function works in Spark. It's like, some people might. So, but got a question here. How important is it to learn Java or Scala since a lot of legacy production code is written in these two languages? I think it depends on where you're working, right, or the places you want to apply to. If they are using Java or Scala, and your goal is to work at this company, then that's the reality of it. You're going to have to know Java or Scala. So it is what it is. So that's kind of a blanket answer across the board. You will find in a lot of these, the Apache projects, especially, JVM languages, Java Virtual Machine based languages are very, very common, right? So you should know these at some point, but I would say like have a reason to learn them, right? Your time is very limited. So focus it on things where you're going to have the most impact. Like I wouldn't just go learn Scala just for fun like that, unless you have a lot of time on your hands. So it's a question here. What have you found most challenging to date as a data engineer, and how would you advise new folks in the field tackle them? It's a big question. I would say up to now, the reason I wrote this book is because I did notice that the conversations around data engineering were mainly tool focused and tactics focused versus, stepping back and understanding the broader picture of data engineering and what the craft is and what the field is. And so I would say that knowledge and education is actually the thing I see as the biggest challenge. We talk about data engineering all day, but I doubt a lot of us could say what it really means and how we do it. So that's a big goal of mine, is to help address that. There's a question here. If you're a mid-level or senior data analyst, data scientist, and you're trying to become a data engineer, should you apply for junior roles? Yeah, I think so. So it depends. I'll caveat that. It depends, like, what else do you bring to the table, right? So if you're going kind of, an internal hire at a company, you bring a lot of domain knowledge, which I would argue is the harder thing to understand. And so, you could probably more easily become a data engineer or switch whatever path you want, really, because you understand the business. Again, like I said, you need to understand the business that you work in. That's so key, and so, like, I would say underestimated as a something you should pay attention to, because we have the word engineer in our titles, right? So or scientist or analyst. So we think our job is to do analytical stuff or engineering stuff or whatever. So let's get in the queue. We only have 5 minutes left, so I'll take one more question. But also often we focus on what our title does and not necessarily on what the purpose of the business is. And so I'd urge every one of us to really take a step back and you know, in your role, you know, as you're applying for a job, you know, understand, you know, is what what do I need to do in order to get this job? If I have to go to a more junior role, sure. But if I bring something to the table that, you know, it's much easier for me to make that transition, then maybe you can apply across the board. I think it just depends in your background as well. So, what was my first project I handled as a data engineer? I think it was before I think it was before data engineering was really a thing. I was working at so back in 2012 or something like that. I was working at an early machine learning startup, and I quickly realized that so it was automated machine learning. So you can imagine back in the day, 10 plus years ago, this was kind of a new concept. But I quickly realized the algorithms piece, right, was actually the easier part, and building a lot of the infrastructure around, you know, automated feature engineering and, you know, I guess early versions of feature stores and all this other stuff that, you know, take for granted. Like we had to build all this stuff, and there's no playbook for it. You know, hosting models and all this stuff. Like you had to figure this stuff out. There was no playbook, and so that was my first project, I would say. And I did this out of necessity because there's nobody doing it. So that, yeah, but again, I think that, yeah, I don't know that people would have that same experience these days. It was a very much a point in time thing. So I got room for one more question here. Animish asks how to look out for projects. That's an interesting question. It's a very broad question, so I'll give it very. Um, I'm not sure if he means portfolio projects or what, but you know, the advice I would give if it is pertaining to portfolio projects, again, I would say just, you know, you gotta, there's the old quote, you gotta kind of skate to where the puck is going, right? So it's the intersection of like where the puck is going with your interests, right? So that's how I would answer this. Like you gotta do something that's interesting to you, because otherwise you're gonna lose motivation. At the same time, you know, you want to make sure that the projects you're working on or you know, present and future proof, right? So you don't want to work on something where it's you know, working on COBOL or something and building data pipelines out of that. That wouldn't make a lot of sense. So um, cool. Well, I think we're about up for time here. So really do appreciate the audience. Great questions, great interaction. I hope you have a great you know, time at ODSC, and feel free to hit me up on LinkedIn. You know, feel free to message me there if you have any questions. So thanks for your time.